Standard form of a quadratic function. So as we mentioned in a previous lesson, a standard form of a quadratic function is when you have f of x or y is equal to ax squared plus bx plus c. So when you see something in this form, you know you're dealing with a quadratic function. In a previous lesson, we also pointed out how to find the vertex, the axis of symmetry, maximum, minimum, and domain and range. But when we were looking at that in the previous lesson, we were looking at it from the standpoint of a quadratic function in vertex form. So when it's in vertex form, it's easier to pull the information out of the equation and pick up all those pieces that we're looking for. With the standard form, a little tougher because you don't see it in the equation, but when it's given in standard form, one of the ways that we can get the information is through the calculator. So the first thing we want to do is to graph 2x squared plus 8x minus 2. Here's the equation that they're giving us. So we'll start with that. All right, so here's our graph. We want to be able to see the vertex, so we'll have to adjust the window. So we're going to go to Window Zoom, and we'll zoom out just a little bit so that we could see the vertex, and now we've got it in the window. So the next thing we want to do is actually find the vertex. So the way to do that is to go Menu, Analyze Graph. Now you have to know what you're dealing with, if you're dealing with a minimum or a maximum. In this case, the parabola is opening up at the top and the vertex is at the bottom. So we have a minimum here. The next thing it's asking for is a lower bound. So for the lower bound, we want to have that vertical line to the left of the vertex. And for the upper bound, we want to be to the right of the vertex. So they're showing us here that our vertex is at -2, -10. And the reason I say -2 is basically if you look at this number that they're giving us, the -1.9 followed by all of these nines, for all intents and purposes, is a -2. So -210 is our vertex. And that's what they're showing us here. They've got the vertex at -210, which is what we found on the calculator. So we have the vertex. The next thing they want is the axis of symmetry. So for the axis of symmetry, we know that's going to be the equation x equals h. Well, if our vertex is -2, -10, that means that h is -2 and k is -10. So x equals h, our axis of symmetry will be x equals -2. So we have the axis of symmetry. Next thing they want to know is, do we have a maximum or a minimum? So we mentioned that before when we looked at the calculator. Because the opening is at the top and the vertex is at the lowest point, we have a minimum. And we said that the minimum value is going to be whatever number k is. So we have a minimum here with a value of -10. So we've taken care of minimum and maximum, and then the last thing they're looking for is the range. And we said that in a minimum, the range is always going to be y is greater than or equal to k. In this case, k is -10. So y is greater than or equal to -10. If they had asked for the domain, again, that would be easy. Even in this form, the domain is always all real numbers. Okay, so again, here, they're asking for the vertex, axis of symmetry, maximum or minimum value, and the range. So let's get this set up. We'll even include the domain, and they're asking specifically for the range. All right, so same thing. What we need to do is to key this into the calculator. So this one is negative 3x squared minus 4x plus 6. Okay, again, we want to be able to see that vertex in the window, so I'm just going to zoom out a little bit. And now we can see the vertex. So first thing is to find that vertex. So again, it's menu. We have a maximum this time because the vertex is at the very top of the function. And then we want our lower bound to the left of the point and upper bound to the right of the point. And this is what we get for our vertex. So if we went to the, if we round this to the nearest tenth, we could say that we have a vertex of negative 0.7 and 7.3. So now the axis of symmetry again is x equals h. Again, this is h, that's k. So we have x equals negative 0.7. Since, again, looking at the graph, we have an opening at the bottom and a vertex at the top, that makes this a maximum. And this one, we could say will have a maximum, and the value will be k, which is 7.3. The domain, as always, is all real numbers. And the range, since this is a maximum, it'll be y is less than or equal to k. K again is 7.3, and we've got all the pieces that they're asking for. Here are just some properties of the quadratic function that we need to make sure we understand. We know the first couple of these where the graph of f of x equals ax squared plus bx plus c is a parabola. So we know that. We've seen that the last couple of days. We also know that if a is positive, the parabola is going to open up on top and the vertex will be at the bottom. We know that if a is negative, that the parabola will open up at the bottom and the vertex will be at the highest point. Here they're showing us the axis of symmetry is x equals negative b over 2a. We use this if we want to find the vertex algebraically. So it's a little equation that you're going to want to remember. We're going to use this when we graph quadratic functions. So this is the equation for the axis of symmetry. Negative b over 2a itself is the x coordinate of the vertex. Okay, the y coordinate of the vertex, well, y is f of x. If x is negative b over 2a, then f of negative b over 2a will be the y value. The other thing to remember is that the y-intercept occurs at 0, c. So whatever c is, whatever this value is in the equation, is going to be where the parabola crosses the y-axis. So the graphs on the bottom show us, again here, they're showing us that a is positive, opening is at the top, vertex is at the lowest point. The red line, the red vertical line, is the axis of symmetry. The equation for that axis of symmetry, x equals negative b over 2a. You notice that it's crossing the y-axis right here at c. 0, c is the y-intercept. And then the vertex here are the coordinates negative b over 2a and f of negative b over 2a. Right? Remember that negative b over 2a is x, and f of negative b over 2a is y. In the other graph here, same idea, same concept, everything the same, except in this one, a is negative, So that's why we have the opening at the bottom and the vertex at the very top. So here they want us to actually graph a quadratic function, y equals x squared plus 2x plus 3. So the first thing when you're graphing a quadratic function, the first thing to write down in your paper is that equation, x equals negative b over 2a. We want to calculate this. We know that 1 is a, 2 is b, and c is 3. So negative b over 2a, that'll give us x equals negative 2 over 2 times, in this case, a is 1. So x equals negative 2 over 2. That makes our equation x equals negative 1. So that's the x coordinate of the vertex. That is also the equation for the axis of symmetry. Once we have that, the next thing we want to do is set up a table of values for x and y. So what you do is take the outcome of the calculation you just did, which is negative 1 in this case, and put it in the middle of the table. Up here we want consecutive integers less than negative 1. We need 3 of them. So that would be negative 2, negative 3, and negative 4. Down here, we want 3 consecutive integers greater than negative 1. So that's going to be 0, 1, and 2. We need the corresponding y values for those numbers. So we could either take each x value, plug it into the equation, and find the y value that corresponds, or we can do this in the calculator and be able to get all the y values at the same time. So let's take a look at that. So we want to graph in the calculator x squared plus 2x plus 3. And that doesn't look right. Let's try that again. One more time. X squared plus 2x plus 3. There we go. So we're not so much interested in the graph right now. What we're interested in is completing that table of values. So what we want to do is go to the home screen, get a list and spreadsheet page, and the way to get the table of values is menu, table, switch to table. Since I graphed the parabola in F1, that's where I want my table. So here's the table of values. You notice that we started our table at negative 4. So we'll just find that here. And we'll copy all the y values that correspond into our table. So our corresponding y values are 11, 6, 3, 2, 3, 6, and 11. What's left now is to actually plot these points. So let's see, we have negative 4 and 11, so that'll put us up here. We have negative 3 and 6, negative 2 and 3, negative 1 and 2, 0, 3, 1 and 6, and 2 and 11. All right, so all the points are plotted. We're just going to connect them as smoothly as we can. And we have a parabola. We just need to label it. So we'll label the axes, x and y, and the equation, y equals x squared plus 2x plus 3. So when you're graphing these for homework, on a test, on a quiz, whatever it is, you should have all of these components here. starting with the equation, coming up with the x-coordinate of the vertex, right? Because here's our vertex right here. Creating the table of values, plotting all the points, and then labeling everything. So we have our graph of y equals x squared plus 2x plus 3. Here they want us to graph y equals negative 2x squared plus 2x minus 5. So same thing, we're going to start with x equals negative b over 2a. So we're going to plug in for b. B is 2, so makes it negative 2 over 2 times negative 2. So we get x equals 1/2. Set up our table of values. So we're going to put the 1/2 in the middle of the table. Now we're going to use integers, so that'll be the only fraction. We'll have 0, -1, and -2. And here we'll have 1, 2, and 3. So 3 integers less than, 3 integers greater than. We go to the calculator. And key that in. So it's negative 2x squared plus 2x minus 5. Again, getting the table of values is what we're most interested in right now. So menu, table, switch to table. I'm in F1. Okay, and our table starts at -2, and we copy all of the corresponding y values into our table. So we have -17, -9, -5, -5, -9, and -17. So now you notice that we don't have a value here in our table because our table is only showing integers. So we have to figure that out on our own. So we'll go and get a calculator screen. So I'm going to put 1/2 in for x. So negative 2x squared, and then plus 2 times 1/2 minus 5. Gives us -9/2 or -4.5. So I'll put -4.5 in to the table. So now we have the whole table complete, and we're ready to plot the points. I don't have enough room for the -17. I'll start with -1, -9. Then we'll go from there to 0, -5. It'll be 1/2 and -4.5. So that'll put it there. 1 and -5, and 2 and -9. So we're ready to connect them. And we have a graph. Again, last thing to do, label everything. So the axes and the equation. And we have a graph. So again, all of these components on the paper when you're graphing on graph paper. All right, so one of the concepts that we want to cover in here is getting the vertex form of the equation that's already in standard form. So here they want the vertex form of y equals 2x squared plus 10x plus 7. So as you recall, vertex form of a quadratic, y equals a times x minus h squared plus k. So in order to write the equation in vertex form, we actually need three things. We need to know the value of a, the value of h, and the value of k. So the first one's easy. A is already here. So we already know that a is 2. For h and k, let's just graph the equation in the calculator. We'll find the vertex and we'll have h and k. So we have 2x squared plus 10x plus 7. Let's get an x in there. There we go. And there's our graph. So again, to get the vertex, it's menu, analyze graph. We have the opening at the top and the vertex at the bottom. That makes this a minimum. The lower bound would be to the left of the vertex. Let's try that again. Left of the vertex, upper bound to the right of the vertex. Okay, so it's showing that our vertex is at negative 2.5 and negative 5.5. So let's go back. So h is negative 2.5 and k is negative 5.5. So now we have all the pieces we need to write the equation. So here we go. We have y equals a is 2, x minus h is negative 2.5, plus k, so minus 5.5. So the only thing we have to do is clean this up in the middle. So we have y equals 2 times x plus 2.5 squared minus 5.5. So here is the equation in vertex form. Okay, here they also want the vertex form of y equals negative x squared plus 4x minus 5. So again, we need a, we need h, we need k. A, we already know, is negative 1. We need h and k. So we're going to graph that in the calculator. So negative x squared plus 4x minus 5. Okay, so we have a graph. We need a vertex. So again, menu, analyze graph. This time the opening is at the bottom and the vertex is at the very top. So we have a maximum. Wants a lower bound to the left of the vertex, upper bound to the right of the vertex. So we have a vertex of 2 and negative 1. So h is 2, k is negative 1. So to write the equation, y equals a times x minus h squared plus k. So in this case, it's y equals negative 1 x minus 2 squared minus 1. And we have our equation in vertex form.